Write the equation of the tangent line to the curve y equals the square root of x divided by x minus 2 when x is equal to 3. So remember, when we're writing the equation for any type of line, we need to know a point on the line and we need to know the slope of the line. So we'll start with the point. We know the x value over here, that x is equal to 3, so we just need the y value. So we need to find y of 3. In other words, the output. So when x is equal to 3, what's the y value? And in this case, the output, the y value, will be the square root of 3. So the point of tangency, we often call it, the point we're basically given is x is 3 and y is the square root of 3. 3 comma rad 3, or radical 3. So now we need to figure out the slope. So remember, the slope of the tangent line is going to be the derivative. So we need to compute the derivative at 3. Now, we need to do a little analysis on this function because this function is the square root of x divided by x minus 2, which means this function is a composite function. So a composite function is a function inside of another function. So this will require us to utilize the chain rule to find the derivative of this function. So let's start with a little rewrite. It's always a good idea to think before you work. And because we have a square root, we know we can rewrite this as the quantity raised to the 1/2 power. So we'll have x divided by x minus 2 all raised to the 1/2 power. And that might help you see the composite function more clearly. I'll even write out the two parts. We have an outer function, which we often call f. Our outer function is something to the 1/2 power. And then we have that inner function, and the inner function is the x divided by x minus 2. So let's utilize the chain rule to compute the derivative of this function. So the derivative of the outer function, the derivative of something to the 1/2 power, will be the 1/2 something to the negative 1/2 power. Remember, I'm utilizing the power rule there. So that would be 1/2 times the original quantity raised to the negative 1/2. Now, when I say the original, we're talking about the original inner function. So the original inner function was function g. So that would be x divided by x minus 2. So in terms of the chain rule, what I've done here so far is we have taken the derivative of the outer function and we have evaluated it at the inner function. So what we've done is f prime of g of x. Now the rest of the chain rule says we have to multiply this and we multiply it by the derivative of the inner function. So we need to multiply it by g prime. Well, when you take a look at function g, because g is a quotient, x divided by x minus 2, we've got to use the quotient rule to determine the derivative of function g. So here's the quotient rule. I'll do that in red. So the quotient rule says we're going to take the denominator, the low, which is x minus 2, low d high, multiply it by the derivative of the numerator. Now the numerator is just x, so the derivative of x is 1. So that's low d high minus high, which is just x, multiplied by the derivative of the denominator. So the denominator is x minus 2, and the derivative of x is 1, and the derivative of 2 is 0 because it's a constant. So the derivative of x minus 2 will just be 1. And then that's all divided by the denominator squared. So x minus 2 squared. Now we tackle simplifying. So we have 1/2 times the quantity x divided by x minus 2, all raised to the negative 1/2 power. And then what I have in red here is really going to just be x minus 2 minus x. So the x's will subtract out. So we'll end up with the minus 2 divided by x minus 2, the quantity squared. Now we can simplify quite a bit here. It's really up to you. Ultimately, we're going to need to substitute in 3 because we need to find the slope at x equals 3. I'm going to go ahead just for practice. I'm going to keep simplifying a little. I can see that the 2's will divide out. And then remember, if you don't really like that negative exponent, remember that negative exponent will cause the numerator and denominator to switch. So this would end up creating this quantity of x minus 2 divided by x, and then it would be raised to the positive 1/2 power. Those are equivalent. So that's a nice way of getting rid of the negative exponent. We still have a negative 1 in the numerator over here, and then we have x minus 2, the quantity squared. Now, when I see that I have a quantity raised to the 1/2 power, I prefer to write that as a square root. So that's just a personal preference of mine. I would write this as the square root of x minus 2 divided by x, multiplied by negative 1 divided by x minus 2, the quantity squared. Now, again, there are multiple ways we could continue simplifying this in different ways. It's really up to you. I'm going to stop here, though, because I ultimately want to find the slope at 3. In other words, y prime of 3. So I'll take my derivative, and I'll substitute in 3 at this point. So the square root of 3 minus 2 divided by 3 multiplied by negative 1 divided by 3 minus 2, the quantity squared. So let's keep simplifying. Looks like we're going to have the square root of 1/3 multiplied by essentially negative 1. So my derivative evaluated at 3 is going to be the negative square root of 1/3. And remember, that's going to be the slope of your tangent line. So back to the original problem, which was to write the equation for the tangent line. We now have all of the necessary pieces. We know that the point we're using is 3 comma square root of 3, and we know that the slope of the tangent line is the negative square root of 1/3. So given that this point is not the y-intercept, I think it's much easier to use point-slope form to write the equation for the line at this point. So point-slope form would be y minus the y value of the point, which is the square root of 3, is equal to the slope, which is negative 1 divided by rad 3, times x minus the x value of the point, which would be x minus 3. So for some instructors, you would be done here. There's the equation for your line. However, I know some of you are bugged by that slope being unrationalized. Maybe you don't like that negative square root of 1/3. So let's put some other options down here. So you can either please yourself or maybe your instructor. So we know that the square root of 1/3, if we were to rationalize that, that would also be the same as the square root of 3/3. So here's another alternative way of writing the equation for the tangent line. Perfectly acceptable. But I still know there's a few of you that are looking at that going, you don't like it because it's not in slope-intercept form. So for the rest of you that are just dying to distribute and really like this in slope-intercept form, I'll try to please you guys too. Let's distribute. So that would be negative rad 3/3 times x plus rad 3, which if we finish that off and we add the square root of 3 to the other side, we'd have y is equal to negative rad 3/3 times x plus 2 rad 3. And there's the slope-intercept form of the tangent line. So you really have 3 options. These are all equivalent. They are all equally good in my mind. You can pick which one you prefer.